Bismillahirrahmanirrahim. This is Ahsan Masood Jamali, and I'll be giving you a lecture about a specific topic. So let's just begin formally. So the topic for today's discussion is kinematics of motion in a straight line. Now, the key word here is kinematics. What does this mean? Kinematics is basically the study of motion, and the motion for this particular lesson is basically a motion in a straight line. Here are the contents of this particular lecture, and I'll give you a brief introduction about myself. We'll look at the course objective for this course, which is Mathematics 9709. We'll go through our lecture, we'll discuss the plan for our regular classes, and then finally I'll want to have some feedback regarding this lecture. So as I told before, my name is Ahsan Masood Jamali, and I am in junior year of environmental engineering degree from National University of Sciences and Technology, NUST, Islamabad, Pakistan. I did my A levels from Lahore Grammar School, Johar Town, back in 2018. I have a teaching experience of more than 2.5 years for this particular course, and I have taught 9 students so far. And Alhamdulillah, by the grace of Almighty Allah, all of them have scored really good grades. So, so this particular course, Cambridge International AS and A-Level Mathematics 9709, basically equips the students with skills such as analytical skills, working with mathematical information, modeling situations mathematically, analyzing results, and then reflecting on those findings, and basically the ability to think analytically, logically, and independently. Then the learners of this particular course can apply the skills gained in this particular course and in a wide range of subjects and equip themselves for higher education or maybe employment at any point. So now the lecture, we have some basics in this particular lecture. As I already told you guys, kinematics is basically the study of motion. So motion involves either some distance covered at some particular speed. So what is distance and what is speed? These are very common terms that are used in our daily life. Distance is the length that is covered, and speed is the distance per unit time. And both of these are scalar quantities. Now, you guys must have studied scalar and vector quantities in your physics, but we're going to revise those here. Scalar quantities are the ones that have magnitude only and no particular direction, whereas the vector quantities have magnitude as well as a particular direction. Now, the two key terms are magnitude and direction. Magnitude is basically, let's say that I travel a distance of 5 kilometers. So 5 kilometers is the magnitude in this case. And if I say I travel 5 kilometers towards south, then south is my direction. Displacement, acceleration, and velocity are all vector quantities. They have both the magnitude and the direction as well. So now let's differentiate between distance and displacement. This is an image that has that has a cyclist that is starting from point A and its destination is point C. So the cyclist travels from A to B for about 4 meters, and then from B to C another 3 meters. Let's say that the total distance covered by the cyclist is 7 meters. However, there is an alternate route that the cyclist can use, and it can uh, move from A and reach C directly without stopping anywhere. So that uh, in that particular direction, which is AC in this case, the wait. So in this particular case, AC A to C is the displacement because the cyclist moves from A to C directly without any rest or any stop in between, and it covers lesser distance, and it actually takes him lesser time to move from A to B. So this A to C is the displacement, and if we move from A to B and B to C, we have to cover more distance, which is 7 meters, as compared to as we move from A to C. So now another particular important concept in this particular topic is of displacement time graph. I'll draw this graph on the whiteboard, and then we can discuss all of the concepts from this slide on the whiteboard. Let me just share the whiteboard. So I'll draw the axis. This is distance on y-axis in meters, and we have time in seconds on x-axis. Let's say that the the cyclist travels, and this is the displacement time graph for the cyclist. All right. So there are a few points that are to be noted. For a particular graph, we must have some gradient. And in for a displacement time graph, we also have a gradient. Let me just change the color of my pencil. So let's say that this is some point, and there's this point T1 corresponding to S1. We basically use the symbol S to represent distance. And then there's another point, which is this, and the time it takes to reach this point is t2, and the distance covered is s2 in this particular case. As I told you guys that speed is basically the distance traveled per unit time, so distance over time. And similarly, velocity will be displacement divided by time. And let's see what the expression for the gradient of this graph will be. As you guys must be aware that gradient is basically change in y divided by change in x, or we can call it rise over run. So change in y in this particular case is basically S2, the change in S divided by change in time. So as we can see that this is the formula for velocity. So the important point to note here is that the gradient of a displacement time graph gives us velocity. All right. So this is an important point that we have to take in mind. And now some other important points are also of our importance here. If we see that the gradient for this particular portion is constant and has an increasing trend, and for this particular portion the gradient is decreasing but is still constant. M is used to denote gradient, and increasing it is for this particular case, and in this case the M is decreasing. All right. Since we understood that the gradient is velocity, and if the gradient is constant, then if gradient is constant, excuse me, if gradient is constant, then the velocity is constant because the gradient of the displacement time graph gives us velocity. And if the gradient is increasing velocity, increasing, and vice versa, which means that if the gradient is decreasing, then the velocity must be decreasing as well. All right. Now we'll switch back to our slides and see that these are the important points. As we understood, gradient basically gives us velocity. Straight line means constant gradient, which means constant velocity. And whenever we have constant velocity, we have zero acceleration. These are all the salient features that we can understand from the displacement time graph that we just saw. The gradient of a displacement time graph gives us velocity because gradient is change in displacement divided by change in time. And if an object goes back to where it started in certain time, let's say we'll study this on the whiteboard as well. I'll clear the whiteboard. Let's say that this is some point A and this is some point B of the same elevation. All right. So if I throw a ball from this point which goes upwards and it comes back downwards covering the same distance but in the opposite direction, then the displacement for this will be zero because this is distance covered in positive direction, displacement covered in positive direction, and this is displacement in negative direction. If we sum these, then the resultant will be zero. So therefore, when an object starts from a set point, returns vertical, if it's already at just zero and then so it will length of the videos in just don't pick any value which is like as soon as straight line means philosophy which is not that calculation is zero. Right, so now that's the presentation and now this is an ID follow for later classes. We discussed the pen in our notes we have those, but this is the backtrack that if you have a later practice in third class and a grade was in third class, I did that week and we try to talk about last year's math is all about practice and grammar features is a requirement from Valeem that you have to and take it on board and take into account that how you are performing and what is your performance for a quiz, for a test, and in the regular classes as well. All right, so if you guys have any questions, you can put them forward. I'll be happy to answer those. And please do not feel any hesitation in giving feedback for this particular classes. I encourage feedback and I'll be happy to receive your feedback for this class. These are basically the social media handles for Valeem. You can contact us on our Facebook, to our website, to our WhatsApp numbers, and please do watch the videos for Valeem on YouTube, and you'll get a great idea about how Valeem functions and how you are benefiting from this amazing website and from this amazing platform. Thank you so much. This is the end of our lecture. And if you have any questions, please feel free to ask. Thank you so much. Take care. Allah Hafiz.